Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hello all, and welcome to a new episode of Empowering Tomorrow's Automotive Software Podcast by ETAS. We're exploring the technologies, transformations, and engineering shifts that are shaping the future of mobility. Today, I'm your host. My name is Suresh Sivavarman, and I'm a Customer Chief Engineer at ETAS. And I'm glad to be your host, and I'm looking to talk about different trends in the automotive industry with respect to cloudification and how the play of AI in that world. To set a context for today's episode, we'll be talking a lot about how engineering teams across the world, including leadership teams, are focused on four themes: data activation, AI and engineering workflows, cloud-enabled shift left, and SDV backend transformation. What we know is these are not just buzzwords, but they're becoming core drivers of transformation and competitiveness, and it's also increasing the velocity of development. So today I have a guest with me. His name is Raj Paul. He's the mobility industry leader for the Americas and global industry leader in automotive at Microsoft. He's got over 20 years of experience in the automotive industry with in-vehicle innovations, connected services, and digital infrastructure, as well as transforming companies into the cloud world. Raj brings a powerful combination of technical depth and industry foresight in the modernization journey. We, ETAS, have been working closely with Raj to modernize our portfolio. And Raj is here to bring us a little bit of insights into how the SDV platform can transfer from regular prem tools to cloud-native engineering applications. So, Raj, thanks for being here. We're glad to have you on the show.
Thank you, Suresh. Appreciate the opportunity. Looking forward to this good discussion with you. I know we'll had a lot of conversations, a lot of them philosophical as well, around these topics. I'm really looking forward to this conversation.
Perfect. So let's get right into it. So I think one of the first areas that I wanted to focus on was something that's of deep interest to me, which is data-driven decision-making. Historically, data-driven decision-making was always limited by the capability of the tools that were in our hand. We always had data, but we didn't know how to properly utilize it or how to effectively utilize it to make decisions that can impact how close we can get to a real-world model. And we hear that data is kind of like the new fuel, right? It's driving North American OEMs and activating them to unlock new capabilities. What do you see as kind of in your world as data-driven decision-making? Where do you see OEMs leveraging it?
So, data being the new oil, data being the new fuel, I mean, that's been talked about for quite some time in different connotation. It's a lot more now for the last, I would say, couple of years. What I would say is since the ChatGPT movement, when Gen AI has become the latest thing where everybody's focusing on. You cannot have a good AI strategy if you don't have a good data strategy to back it. Right? So you touched on data-driven decision making. So if you look at organizations today, in my opinion, there's no shortage of data. Right? We'll had the capability to collect data, telemetry from vehicles for quite some time now, and every OEM's maturity on the granularity of the data they can collect probably varies, but the capability to collect data has been there. I mean, I'll have the privilege to work in this industry from a connected vehicle standpoint, probably since very early days when OnStar started this. But then over the years, initially, what was holy grail, connecting to vehicles and all that, those are all now becoming table stake. But on the flip side, how to put the data to use is still a challenge even today. So for me, when you talk about data-driven decision making, one of the most talked about topic today is how can we bring down the overall development time. While the focus has been on how to bring the development time, I think every OEM is taking a step back now with tier ones like you to figure, hey, we have this data. Why can't the decisions we can drive from the data can actually play a bigger role to bring the overall development time, and is not about cutting corners and then trying to essentially optimize the overall timeline. So we see everyone basically looking at bringing down that development timeline using the metrics and insights they can get out of the data they have. The data could be vehicle data, and trying to understand what is happening in the vehicle and reacting to a much better way. But it could also be telemetry you can collect out of your own CI/CD pipelines, so that you can actually try to do better in redefining your pipeline if it makes sense, whether it's collecting quality metrics or development metrics and whatnot. I think there is all kinds of data which can play a role in the decision making process.
I think the decision making process is very clear, but what are some gaps to actually make those decisions, right? I think what we've learned in the industry today is there's data, there's a vision of how we can make those decisions happen. But I see cloud as kind of the bridge to enable that, right? So can you explain a little bit about where you see the compute power of the cloud be actually being able to enable this data driven decision making compared to where in the past we were limited by PCs?
In the past, there were two scenarios which were pretty common. One is how a developer was more PC centric, right? I mean, I have a tool, I have my development tools, I have my test tools, and I'm working on my PC and I'm testing. Then, of course, the whole concept of the whole data center started becoming prevalent. I mean, what we call on prem today, where obviously there were collaboration patterns where it's beyond your PC, but now you're dealing with the back end of service to essentially help you collaborate. But the paradigm shift we have seen now for quite some time now is as and when these on prem services or servers move to the cloud, that collaboration becomes a lot more easier for developers because now you're dealing with a common plane in the cloud for development and for collaboration. And I think that removes a lot of the challenges and bottlenecks between organizations, between developers when they are actually working on a common code base. And this not just works within one region, it actually plays a much bigger role when teams are distributed across the globe working on the same code base as well. So the cloud is now becoming the common ground to bring things together and helping that collaboration and then helping with that decision making process from the data which can get used over there.
So I think what you're saying is the old classical siloed mentality can be kind of closed off here a little bit, right? Because one of the things that I always see is that in engineering, you have a very siloed environment of how they handle their work. Then you went into manufacturing, then you go into service, then you go into the end customer, right? But in this world where cloud becomes a bigger source of data storage and data decision making, you could work in a world where data coming out of manufacturing and service can impact your decisions in engineering. And this kind of closes the entire loop of how you can have a end-to-end viewpoint of how you make decisions based on not just the data you have in front of you today, but data you may have years from now. Do you see this happening now in the real world where people are starting to see this as a proactive approach to using data that's further down the life cycle to make decisions on product information today?
So, a classic example to the scenario which you're talking about, Suresh, is quality data. Right? OEMs have had quality databases for a long time, and the quality data gets fed from different sources, including what happens at the service bay. This quality data obviously is within the manufacturing organization, a manufacturing and quality organization, I would say. But then how you can tie things together from an overall end-to-end tooling, that's been a challenge because a quality database, there are certain organizations that will have access to that quality data. Then if you look at the connected vehicle data is probably another part of the organization. Your product development aspect of things, but like for example, where you guys fit in with a lot of the tools you have, all these data in a typical enterprise reside in silos. But breaking that silos and then bringing the data together so that you see a continuum of what happens to a vehicle, not just currently, but the past historical data, if that problem was seen probably let's take 4 or 5 years back, and how can you relate to the learnings and what kind of recalls were done and what was done to that fix, that whole timeline of events pertaining to a part or a vehicle or a particular feature is a lot more possible now with some of the compute and the data storage capability which the cloud can bring. The problem of silos is not a problem unique to this industry. Data silos, I would think a lot of the industries have a problem, which is more a classic enterprise data governance problem. But more relevant in our industry, being an auto manufacturer, you have a lot of players in our world, right? Whether it's an OEM, a tier one, or a part supplier. So I think consciously building that pipeline so that you can learn from the past, not just look at the current data and build your data pipelines, I think will help in the decision making process.
So I think to add to that, a decision making process and cloud is the key word here is efficiency, right? We want to get things done faster. But another area that the industry is really focused on is how we can blend not just the cloud compute power, but also AI into into our workflow. How can we use AI and cloud to modernize engineering workflow, engineering efficiency, and then using the data that we've collected and having AI analyze that data means that we can even get more insight quicker and make decisions faster. So I want to talk a little bit about everybody says they're using AI, right? The industry says everyone needs to use AI. They are using AI. But as Microsoft, you guys are heavily involved into the integration of AI solutions into your day-to-day work, not just in automotive, but in your regular business practices. What do you see for the automotive industry to actually ensure that AI becomes a meaningful adoption, right? It's being used in the right context, not just for the sake of using AI, but there's some value coming out of it. Where do you see AI driving that for auto?
So it's a pretty hot topic, and I think this question will probably warrant me answering it from different vantage points. So let's start with the first vantage point. The first one is developer productivity, right? And engineers developer productivity, right? So the tools which a developer or an engineer can use and then try to gain productivity, that's one of the lowest hanging fruits, I would say. When I say the lowest hanging fruits, whether AI is infused on the day to day development from an engineer standpoint, like for example, in our world, for example, GitHub Copilot, right? So we have coding assistants, as I would say, to help the development aspect of things. We are partnering with you to infuse AI into your tools, which is another set of tools that engineers are going to use. And if AI can essentially help streamline the process, get them to be more productive, great. And then now let's look at the testing aspect of things from an engineering standpoint. If I can do test case generation a lot better, if I can automate some of my tests, some of the tests which I am used to doing manually, or even if I basically have to do integration testing, and there's a lot of things which me as a developer can actually leverage AI today. We say Copilot, Microsoft Copilot is the UI for AI. It is not just for your general knowledge questions, but it's also your UI for all those agents which can actually power my day to day development task and I can make a developer more productive. So that is one aspect of things I would say is an easy thing for a developer to basically look at and leverage AI. As I said, both using tools from us, tools from you, and in general, how AI can play. That is one aspect of things. Now, let's get into a little more complex scenarios. We talked about in the previous conversation about the amount of data which sits in an enterprise. Specifically, let's take vehicle telemetry. There is historical information, there is runtime, real time information being gathered by the vehicle. And we also talked in our industry about predictive analytics, proactive monitoring, and how can we essentially avoid an expensive recall, which means the capability one to store massive amounts of data, the capability to get insights from the data leveraging AI, so that you can predict a failure even before the failure becomes a lot more common, and not just stop there. Look for a fix, or probably even kick off a development tool chain to basically find a fix, and then try to essentially update the vehicle so that the recall is not expensive or probably doesn't even happen. So this capability is not easy, but I think with the power of AI, power of the cloud, I think those kind of tooling and tool chaining and developer tool chain is possible today with the way technology is moving. And I see that's a pretty powerful use of AI coming in as well. Outside of this, let me use my last example. We our classic B model, which is a which is something which engineering and product development adopt quite a bit with most OEMs or all OEMs. The streamline process, I'm struggling to find the word here. I'm not going to say waterfall exactly, but on the flip side, there is waterfallness in the V model. But now just imagine I can use agents to actually help me with functions within the V model so that one, I can optimize that process so that I can actually condense my development time. There is a lot of value in leveraging agents around the V model. What we are seeing out there is we see players like you come out with your own agents, which can actually help within the V model, either for testing or even trying to help with requirements gathering, for example. I mean, we have tools for that leveraging AI. So there are different aspects of AI which can play a role within that V model to bring the development time. One of the common things which every OEM is looking at is how to condense the development time so that they can compete better with new age OEMs and with China OEMs. Which means leveraging AI to bring the development time around the V model. I think there's a lot of benefits around that, in my opinion. I think I touched three vantage points. There are more vantage points. More than happy to talk, but I think these are some of the main pivots I can think of.
So I'm a huge AI early adopter. I use it for everything day to day. But one of the things that I also face is engineers don't necessarily embrace it. A lot of people are sometimes nervous about it or don't fully trust it, or there's just general resistance or this fear that it's going to take someone's job, right? Whereas Microsoft do you guys see as a means to have more users embrace AI and have users believe that AI is a way to speed up their day-to-day work, but without taking the value away from what they provide, right? Where does AI deliver its value first? How do you sell this to engineers so there could be a more mass adaptation of AI? Because as you said, AI is a big part of the final solution, but it goes hand in hand with cloud. Having the two together, you have the mass benefit of shifting left or moving towards a faster development cycle or getting to market faster. So where's the resistance? Where do you see the resistance?
I'll take a step back and then I'll get your point. A China OEM was not the focus until recently. It used to be new age OEMs. The general belief was when a traditional OEM is looking at a 4 to 5 years for a product to get launched from development inception to launch, but a new age OEM in general is believed to be around 3 years. But now the comparison is China OEMs are around 2 years. So when you're thinking about bringing 5 years to 2 years, I'm not going to debate about how valid the 2 years is, but just for discussion argument's sake, the expectation is to cut 50% development time. So if you put that in perspective, are we really trying to get rid of an engineer here? No. What we're trying to do here is literally, if you take the English meaning of co-pilot, I am looking at co-pilots helping engineers to basically pilot whatever they're piloting much faster. So that is the way I would look at the world, where it's a co-pilot trying to help you and get you more productive, because the goal here is to cut down the overall time of development to half, right? If not more. That's number one. Number two, as with any technology, there is always going to be an adoption curve where there is going to be skepticism, cynicism, right? Paranoia. You can talk about all the English words. And to add to that, when AI started off, we also had the whole problem of hallucination, right? Are the answers which an OEM, but which AI is going to give is really 100% foolproof? So I'm going to use a case study which is very published very widely from by us and Toyota. Toyota, the way they use agents today, I mean, there is a program which they launched called Obeya. Obeya, I think in Japanese means large conference rooms. They experimented with AI in their powertrain group, and now they're rolling it out, where they try to solve multiple problems. But I'll just try to hone in on two problems which drew my attention. The first one is there's so much of institutional knowledge within a tier one community like yours or an OEM, which for all the documentation you can do, sometimes there's a fear of that institutional knowledge walking away. But now imagine an agent is able to essentially preserve that institutional knowledge. When a new developer comes, he has access to this agent to basically tap into that institutional knowledge, which we talked about quality data. I mean, it could be anything in the past. That's super valuable in that regard. I would think anybody who has access to that knowledge with a very simple conversational interface, I'm sure they would love it. Right. So that's one way of looking at the Obeya story. Another way of looking at that Obeya story is from a productivity standpoint. Today, when you basically bring engineers together to basically whiteboard and have a conversation, the amount of prep which happens or amount of smaller meetings which happens before you get into decision making mode is human intensive today. And if a fraction of that can be eliminated, where the developer can deal with an agent who's an expert of a particular function within that department, in this case, the powertrain department, then I think your productivity obviously increases because I'm not waiting for a human's availability to have a meeting because now I'm dealing with an agent to give me that knowledge so that I am well prepped. And here again, we're not eliminating the human. The amount of time it gets to a decision making process, bringing the right set of humans, we all know within organizations we spend a lot of time. So if I can take a fraction of the time, I think that adds a lot of value. So, going back to your question, why is there adoption hindrance? I think, as with any technology, we have some challenges. But then I think as people start using it and then they see value, I think some of the fear of being displaced, I think, is going away. Then I think the adoption starts increasing as well, which we are seeing, by the way, out there.
So I think you're dead on, right? The fear of displacement, you're changing it to embracing the change, right? But how do you maybe embrace change is by showing measurable gains in engineering efficiency. And I think this is one way that as more people use it, they'll start to feel it and they'll start to see it frees up some capacity for them to do more value added work. When we talk about value added work, we say AI is a piece of it, cloud is a piece of it, but then we always hear this mindset shift left validation, right? We talk a lot about the industry about SDV transformation and all this kind of stuff, and we'll get to that shortly. But we also talked earlier about the V model, the traditional V model. The V model is you do all your coding, your requirements on one side, and your validation on the other side. But this was time consuming and kind of slowed down your development cycle in comparison to China, right? And the way they work. So there's a lot of stuff going on right now about how do we shift left? How do we embrace the fact that we have AI, we have cloud, but at the same time, this enables to work in a virtual environment with virtual ECUs. And this means that we can detect issues earlier without even having physical hardware available. Where does Microsoft see this shift left mindset really driving? And where do you think that it's going to bring its biggest presence in the automotive industry over the next, let's say, 3 to 5 years? Because there's a lot of activities going on around virtualization right now.
So there are two aspects to this, Suresh: simulation and virtualization. I know we'll talk about software defined vehicle soon, but I'm going to touch a little bit of software defined vehicle to help answer this question. Right. The decoupling of software development from hardware development has been talked about for quite some time in our industry. But the reality is, how much progress have we made in that regard? Initially, when software defined vehicle was talked about, the initial days, the comparison obviously was the mobile phone. Right? And the comparison was about, okay, if the mobile industry can monetize services and in-app purchases, for example, as an example, why can't the car industry do the same? Right? Comparison of it is a mobile phone on wheels, data center on wheels. I mean, you have a lot of interesting comparisons to the vehicle. End of the day, the vehicle is a vehicle. It has its own sets of challenges which the mobile phone will never have, particularly when it comes to regulation, for example. So what do we do? A waterfall model, hardware then software, is not going to scale, which means it's got to be hardware and software development running in parallel, which means the dependency. I come from days in my earlier days where my first customer when we build software used to be engineering so that they can validate another supplier, hardware supplier's deliverable before they can do anything. My first customer was not taking to production this connected vehicle software, which we did, but more engineering. The reason is they need the piece of software we developed to test their hardware so that that hardware can be tested against somebody else. All these interdependencies is the world we lived with. I mean, I'm talking about not 20 years back. Right? Now, if you look at it, and of course, even in those days, we used to build emulators and simulators so that we can test without that hardware dependency from engineering, so that engineering can in turn use our software. There's a nice nested dependency there. Right? With software-defined vehicle, right? Now, of course, there is ECU consolidation happening inside the vehicle, right? I mean, I'm not going to get into zonal model domain. I mean, I'm not going into the vehicle architecture here. End of the day, we are seeing consolidation happening inside the vehicle. We're also seeing a lot of compute now getting into the vehicle to support some advanced workloads like ADAS, for example. And not just ADAS, even infotainment workloads, so the amount of compute getting in. So now the immediate thinking is, hey, with so much of compute and so much of development happening inside the vehicle from a software standpoint, why can't I virtualize everything so that I don't have to wait for the hardware? That interdependency is has to happen if we have to cut down this overall development time I'm talking about. The simulation needs of a lot of what gets done is compute intensive, which means you can scale up and down at ease in the cloud better than anything else, right? So that is, I don't think there is any argument when it comes to simulation. Now let's get into virtualization. So the goal for us is to, again, ours is a very partner-led approach here. I mean, you are a great example. We partner with you so that if we can help virtualize that ECU in the cloud, then the developer who is working on that ECU doesn't need to work for the hardware so that they can continue development while the hardware is getting big. So the testing can happen when the hardware is available rather than waiting for the hardware to available, because now I'm actually building and working on a virtual environment. So our goal is to essentially create that environment for engineering product development so that development can happen in parallel, both in terms of simulation and in terms of virtualization. And our approach is to provide that platform for partners like you to provide those virtual tools and those simulation tools so that the developer community at large gets to benefit.
And I think there's also another aspect of this, right? As the industry moves towards virtualization, we're also seeing a reduction in the amount of money that OEMs and customers are spending on physical artifacts. So not just hardware modules, but physical vehicles, right? And the more you can shift your development to the left, if we use that acronym here, right? The more you're testing on a virtual environment, the less money you have to spend to build actual vehicles for validation. And this means that you're kind of transforming the business as well, right? You're going from a traditional capex capital expenditure business model to an operating expenditure business model. So your investment upfront is also reduced, and you're actually getting quicker feedback at maybe a fraction of the cost you'd have to invest. So I think there's a lot of driving factors into this virtualization world. But one of the things I want to talk about here is virtualization is something that's come up over the last few years very aggressively. But as OEMs are making that transition to SDV, software defined vehicle, people have, I think customers have realized that it's not something that you're going to just do overnight. You can't just say, okay, I'm going to become a software defined vehicle company. There's a transformation that has to happen. And that transformation has to happen from everything we just talked about, right? There is a transformation towards cloud computing. There's a transformation towards AI. There's a transformation towards virtualization. All of this coming together is going to develop your back end system to enable the vehicles to go into a software defined vehicle environment. So this back end transformation, the question is, how much is it really talked about? You talk, a lot of people, a lot of engineers and a lot of industry specs always talk about SDVs. It's the next big thing. This is what we're going to do. But what does a transformation to an SDV look like from a tooling perspective?
So the best example I like to use in this regard is how OEMs are building. You'd heard about the word data pipeline, and I like to call it as feedback loops, right? In an ideal world, right, an OEM tries to capture all kinds of telemetry from the vehicle, right, so that you can understand what is happening inside the vehicle. And in a lot of the advanced cases, you also want to know what the car is seeing. When I say the car is seeing, you also basically try to tap into some of the camera feeds which come, what the car is detecting, so that you can constantly learn from your fleet of cars. Not test fleet alone, I'm talking about production cars as well. But now, if I have my feedback loops built in such a way that I can detect issues much earlier on, because now I'm looking at an aggregate view of what my cars are seeing from a telemetry standpoint and everything else. And now, if I can essentially now identify problem a lot earlier, and my whole tool chain is built in such a way that it could turn around and send a fix to the car even before the person who's driving the car realizes, more like the amount of updates we get on our cell phone today. That is the world we are marching against. And again, every OEM's Uber goal is to be there, and the maturity of every OEM could be different as well. This is easy said than done. And you talked about PLM and a couple of other things integrating as well. Now, if I extend that all the way to my manufacturing, that is even more harder, but very doable. But that's the world we are trying to go. So when you talked about software defined vehicle, there are multiple aspects which, depending on who you talk to and ask them what a software defined vehicle is, some could say it's a completely feature driven world. I can turn on and off features in the car. I can monetize features in the car. So that is one nice way of looking at software defined vehicle. In order to do that, another way of looking at it is my car is completely upgradable, just like my phone today, so that my car's hardware value elongates because I'm giving it a new breath of fresh air every time with new piece of software coming in, which is the update capability which the car needs to have as well. But regardless of how you look at SDV, in both these cases, building those feedback loops, building those development tool chains, building the testing tool chain, all that becomes very pivotal in order to build a successful software defined vehicle. Today, meaning I'm going to use an example here again, Teams, right? I mean, I'm sure you use Teams. I mean, right? I mean, we all use Teams quite a bit. If you look at the amount of updates we send, we're constantly learning from that software so that we can actually take care of issues and send updates proactively. And of course, one could argue that's a piece of software. We as an organization do quite a bit even with our Xboxes today. So for me now, of course, you have a car, which is a lot more complex thing on wheels on the move. But the paradigm shift we're seeing pretty much with every OEM, again, as I said, the maturity of this could vary from OEM to OEM, is how can I build a feedback loop? How can I build this data loops so that I can constantly learn and recalibrate my development process with the uber goal of cutting down my overall development time, reducing my cost, reducing my warranty cost, and all of that.
I think you used the example of a cell phone, right? If something goes wrong, you get an update the next day. And most people don't even realize it. They just hit go ahead and it's just a part of your day to day life. I think in the automotive world, the one thing we're going to have to get used to is the fact that over the air updates are going to be the future of how things are going to get fixed, right?
Absolutely.
You're connected to the cloud, the vehicle is connected, the OEM or has learned about what's going on with your vehicle or a fleet of vehicles. Before you know it, the fix is going to come across and you're just going to accept it like you have on your phone and you go about your merry day, right? So I think we're heading towards that. I think it's an ecosystem that has to slowly develop and build towards that. And I think that's where we are today. We're at kind of that inflection point where not only are we speeding towards, but we're also kind of slowing down to understand exactly what is necessary from a back end transformation before we can move to the front end of the vehicle to the end user. So I think we're there, we're getting there, but it's not just about feature delivery. It's also about connecting the whole end-to-end life cycle of a vehicle. And like you said, the closed loop portion of it is extremely important. But if we talk about all this, Raj, what does 2026 to 2030 look like from a digitalization perspective? What do you think the industry is going to see? What do you think is going to accelerate, and what do you think might plateau?
So, on one end, I think as part of this industry, I mean, you and me, we all know the competitive threat is only increasing, right? I mean, we have one end of our world doing interesting things, and then we have the traditional OEM base which are doing interesting things, but then the amount of time which takes is obviously a lot more than China OEM. So that I think is a very hot topic, will continue being a hot topic, which means that's I think is a huge forcing function for every traditional OEM and tier ones to relook at how they develop software today and how they develop hardware as well. Right? So that I think we'll see a huge progress when we go into the next decade. Right? So that goes without asking. Now, a couple of other forcing functions which are happening is AI is a board level topic today. There is acknowledgement that AI is going to increase productivity. Of course, there is, as we talked about, there might be some skepticism, there might be some adoption challenges and all that. But on the flip side, we all know how AI could help us in this first pursuit of trying to build things much faster and quicker and probably, hopefully, cheaper as well. Right? So, in order for that AI mission vision to be realized, the next forcing function which will happen is to try to get an act on the data problems, whether it's data silos, trying to understand the data which you already have, and the capability to probably get even more fine granular data. That I think will automatically take care of itself because of the AI thing which you're jumping on, because each one of them are interdependent on the other. I think overall as an industry, I think we will evolve in a very nice way going into the end of this decade. So when the next decade starts, I think if you and me were going to do a podcast again in 2030, I think we can look back 5 years and then look at the progress we've done. I'm a pretty big optimist in this regard. I think as an industry, I think we are heading into a time where a lot of the challenges we are talking about today, I'm pretty optimistic that it will change quite a bit.
So I think at the end of the day, we got to modernize the backbone. We got to experiment early with AI and use data. Right? Simple. Three things.
Yeah.
And we'll be heading into 2030 with a much more optimistic idea and modernized workflow. Overall, I think we talked a lot today about how cloud is a fundamental piece of how we're going to move towards this SDV transformation, right? We also talked about how embracing AI will help efficiency and help getting some of that data more appropriate towards what you want like to use it for. And we understood that it's all a part of a larger transformation, right? Shifting left is a clear direction that we want to head to, because it means you get to learn faster, you iterate faster, you find out things faster, you fix faster. It's this whole quick information mindset. In order to do all this, we also understand that sometimes we have to slow down a little bit, look at the ecosystem, figure out what the ecosystem needs, and build up from there. And it's going to be a transition over the next few years as everybody migrates towards this world. So, Raj, I want to thank you for your time today. It was a great discussion. I think we learned a lot about what Microsoft is doing in the automotive industry and how you're helping support some of that activities. Also, some of the things that ETAS and Microsoft are doing together to move forward on the automotive industry. And look forward to having you as a guest in the future again to talk about maybe 5 years from now how this transformation has actually taken place. But thank you again for joining today.
So Suresh, appreciate the time and the opportunity to have a nice conversation with you. I think you and me have been in this industry for a very long time. Looking forward, I think a lot of the work we're doing together between Microsoft and ETAS, I'm sure will help the industry at large, and looking for a better collaboration with ETAS and how we can bring tools and productivity to this community.
Thanks again, Raj. Yeah, looking forward to furthering our relationship with Microsoft and building on what we have already started, right? Looking forward into the next few years. But thanks again for joining. And thank you, everyone, for tuning in to today's episode of Empowering Tomorrow's Automotive Software Podcast. If you enjoyed today's episode, don't forget to subscribe on Spotify, Apple Music, or wherever you get your podcasts. Feel free to share the episode with your network and leave us a review. We'd love to hear back from you. This concludes our episode. Please check back again for a new one.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software Podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.